Hi, folks. We're going to take a look at some examples of taking limits with functions that have absolute values in them. So we'll take a look at this one here. And I notice that the denominator is approaching 0 as x approaches 5. So it's possible that this limit does not exist. But when I look at the numerator, I see that the numerator is also approaching 0 as x approaches 5. So what that tells me is that this limit may or may not exist. So I'm going to have to do some more investigation here. And when we talk about doing investigation, we're talking about simplifying the expression. Problem is that because of this absolute value, I don't really have any algebra to simplify this expression. So the way in which we work with these functions that have absolute value terms in them is we rewrite them as piecewise functions. So let's go to the side and take a look at how we could write this function. Okay, I'll call it f at x. So absolute value of x minus 5 over x minus 5. And let's see how we can rewrite this as a piecewise function. All right. And this is where we have to remember what an absolute value does to a number. It takes this number, x minus 5, and makes it positive. Thing is that if x minus 5 is already positive, then it won't change at all. And of course, if the number x minus 5 is negative, it turns it into a positive number. So the way we're going to write this as a piecewise function is I'm going to separate it into two parts. I'm going to take the parts where the input is going to be positive, in other words, x greater than 5, because if x is greater than 5, this expression inside the absolute value is positive. And then I'm going to look at the uh, part of the domain where x is less than 5, which is going to make this input into the absolute value negative. Now notice how I don't have an equal sign on either of these, because clearly this expression is not defined for x equals 5 because of that 0 in the denominator. Okay, so let's start with this scenario here where we assume that x is greater than 5. So 5.5, 6, 7, 12, whatever. We know that the result is going to be positive, and we know that the absolute value of a positive number is just the number itself. So when x is greater than 5, this just is the same as writing x minus 5 in the numerator. Okay. But when x is less than 5, in other words, the input is negative, we know that the absolute value takes that negative number and makes it positive. And what I'm going to do is I'm going to use another way of taking a negative number and making it positive, is I'm just going to multiply it by -1. Okay, and let's see that this makes sense. Remember, I'm assuming in this scenario that x is less than 5, meaning x minus 5 is negative. And by multiplying that negative number by -1, I just get its positive version. All right, so it accomplishes the same task as the absolute value did. Of course, the advantage to this is that now I'm able to use my algebraic tools. The disadvantage is that this is not as nice a way, it's not as clean a way as expressing this function here. Okay, but let's see what happens when I do my simplification. Well, here, x minus 5 divided by x minus 5, well, that's just easy. It's just equal to 1. So this function is just equal to 1 whenever x is greater than 5. And here, when I reduce the bottom one here, I just end up with -1. So that means when x is less than 5, this function is equal to -1. So in fact, what would this look like? Okay. If this is 5, it means for everything less than 5, the function is just equal to -1. Okay, and then for everything greater than 5, it would, oops, didn't draw that very well. Let's draw the hole there. So it's equal to 1. It's equal to +1. So it's essentially a function that is a horizontal line at -1 up until 5, and then a horizontal line at +1 from 5 onwards, not including 5. All right, so now that I have this new way of writing the function, well, I can now take the limit as x approaches 5 from the right. But of course, this is just equal to the limit as x approaches 5 from the right of, well, what is this equal to when I'm only interested in numbers that are greater than 5? Well, for numbers greater than 5, this function is just equal to 1. And what's the limit of 1 as x approaches 5? Well, hey, this doesn't change. It's just going to always remain 1. Whereas if I take the limit as x approaches 5 from the left of my function, now I'm interested in looking at those x values approaching 5 from the left. So the function in that case there is just -1. So I'm taking the limit of -1 as x approaches 5 from the left. Well, this is just a constant. It doesn't change as x changes. So it's just going to be equal to -1. Okay, but what I have now is I have the left-handed limit of my function is not equal to the right-handed limit of my function at 5. Okay, hence the limit does not exist. All right, so let's just recap. When I'm taking the limit, in this case here, the only reason why I had an issue is because 0 in the denominator, okay, doesn't exist, but because the numerator also approaches 0, I know that there's a chance that this limit exists. Okay, and in order to be able to solve that limit, I rewrite this function as a piecewise function. And the way I separate it out is the x values that make the input to the absolute value positive, or the inputs that make the absolute value negative. All right, so let's move on to another example, which is the one just below. Okay, screen, there we go, unfroze. All right, so here I'm looking for the limit as x approaches 0 of this same function, but here from the left and here from the right. But the problem is this absolute value of x. So I'm going to do the same thing as I did before, is I'm going to rewrite this as a piecewise function. All right, so I need to split this up into the different intervals where the input of the absolute value is positive and negative. Well, clearly it's positive when x is greater than 0, and it's negative when x is less than 0. Now let's see, oh, sorry, let me just show you that. Now let's see if it makes sense to include 0 in either of these. Well, if I put 0 in the denominator, I get 0 minus 0 is equal to 0. So this function does not exist at 0. So the question is, would it even have a limit there? Well, it might, because the numerator also approaches 0. Okay, so again, keep in mind that the only reason why this might have a limit is because both numerator and denominator approach 0. Let's do what we did before. So when x is greater than 0, well, that on the numerator doesn't change. This expression of x doesn't change. But let's take a look at this absolute value. Wait a minute, we're assuming that x is positive, meaning the absolute value will not change the number, so it'll just be x. Whereas when I look here, when x is less than 0, that won't change, this won't change. But now this number inside the absolute value is negative. So in order to make it positive, I multiply it by -1. Okay? Because this negative number now becomes multiplied by -1, so it becomes positive. The same effect as the absolute value. So let's see what happens when we simplify. Okay, here we've got x over x minus x, so that's equal to 0. So in fact, this function does not even exist for x greater than 0. Okay, because regardless of what x is, whether it's 2 or 3 or 7 or 10, I'm always dividing by 0. Does not exist. Whereas for the second portion, I have x over x minus negative x is 2x. I see that that simplifies quite nicely. This simplifies to 1/2 when x is less than 0. Okay, so if I look at my limits that I'm trying to determine, well, when I'm approaching 0 from the left, my function is just equal to 1/2. Okay, whereas when I approach from the right, what happens? Well, this function is not even defined to the right of 0, and so I have that it does not exist since the function not defined to the right of 0. Okay, so obviously if I can't approach it, it does not have a limit. Okay, now just to kind of show you what this looks like graphically. So before I do that, a recap, anytime you've got a function that has an absolute value in it and you're trying to find a limit where there's a bit of an issue, the best thing to do is to take your function and rewrite it as a piecewise function. And then you can more easily do your algebra and determine the limit. But if we take a quick look graphically here, so here I have the function, the second one we worked on, and when I graph it, we see, hey, it's not defined at all for x greater than 0, and for x less than 0, well, if that's 1, then this is y equals a half. Okay, and in fact, let's put that other one in. Let's shut this one here, and let's put the other one in. So it was the absolute value of x minus 5, okay, and then divided by x minus 5, and we see we get exactly what we had anticipated. It's -1 all the way up to 5, not defined at 5, and then equal to +1 for x greater than 5. All right, that's it for this one.